Let's look at 11.4, and we're talking about common logs, natural logs, and the change of base formula. So let's start with common logs. And common logs means that you're dealing with base 10. And we've done this a little bit on our calculator already. And when you see log on your calculator and no base written, that's assumed to be base 10. So let's just use a couple of these. So let's solve log of 7. So this is base 10, it's not written. And just to remind you what this means, this is really saying 10 raised to what power is 7. And so you can kind of check to see if you have the right answer. This has to be a number less than 1. That's the only way you can get 10 raised to a power is 7. So plug this into your calculator, log of 7. And I'm going to approximate to 3 decimal places. You get 0.845, which makes sense based on this exponent that we wrote down below. So let's do the same thing with b log base 10 of 18. This is saying 10 raised to what power is 18. So I know this has to be a number just a little bit greater than 1, because 10 to the first power is 10, and 10 squared is 100, which is way too big. So again, put this into your calculator, and I'm going to round to 3 decimal places, and you get 1.255. Okay, natural logarithms, you can see this occurring in sciences, in finance, where your interest is compounded continuously. This is base e, and we talked about e when we did exponentials. Remember, this was 2.718. So we're talking about logs with base e. In your calculator, it's ln. So if you see ln, that's base e for natural log. So let's solve some of these on our calculator. So natural log of 7, again, this is saying base e raised to what power is 7. So plug in natural log of 7 on your calculator and you will get 1.946. Do the same thing with natural log of 25. You plug that into your calculator and you get about 3.219. Okay, our calculators have base 10 and base e, but not everything occurs in those bases. So we have a change of base formula, which helps us convert any base to a base that we can use. So I'm not going to show you the general formula. I'm going to show you for converting to base 10, because that's what we can use our calculator for. So if I have log base b of m, the change of base formula says this would be log of m, this is base 10 I'm using, over log of b. And I could do any base. I could do base e, I could do base 2. I'm just choosing to do base 10 here. So this is how you convert. So you can solve now any log, no matter what base it is, by using this change of base formula. So let's practice using this. So log base 3 of 33. So again, just to write what this is asking, this is saying 3 raised to what power is 33. So this is not a whole number. I can't solve this without using log. So I'm going to use the change of base formula. Log base 3 of 33, I'm going to do base 10. This would be log of 33 over log of 3, and then I can use my calculator. The one thing you have to be careful about is that when you put this in your calculator, you get log of 33, you need to end that parentheses to show that's what's in your numerator. Then do the division sign log of 3. Otherwise, it's going to divide this log of 3 into the 33, and you're going to get the wrong answer. So when you do this on your calculator, you should get approximately 3.18, which makes sense because 3 cubed is 27, and 3 to the 4th is 81. So it needs to be a number between 3 and 4. Let's do the same thing with log base 4 of 5. This is saying 4 raised to what power is 5. So I'm going to do a change of base. This is log of 5 over log of 4. Same thing, make sure you end the parentheses with the 5. Plug this into your calculator. You should get 1.161. Okay, here's an example where we're using logs. The half-life of carbon-14 is about 5,730 years. The time it takes for 35 grams of carbon-14 to decay to 5 grams is given by this expression. Evaluate and then round to the nearest year. So I have negative 5,730. Since it's base 2, I need to convert it. So this would be log of 1/7 over log of 2. Again, make sure you put this 1/7 in parentheses. Put this into your calculator, and I'm going to round to the nearest year, so I get 16,086 years. Okay, and the last example is of finance. When interest is compounded continuously, we use the formula A equals PERT, or PERT, to kind of help you memorize that. Suppose you invest 1,000 into an account earning 9% interest compounded continuously. How long would it take for the investment to double? So A is the amount that you would have after a certain amount of time. P is your principal, so that means how much money did you start with. R is your interest rate. Remember, you have to write that as a decimal. And T is your time. Okay, so you know your principal is 1,000 here. You know your rate is 9%, so 0.09. You're trying to find time, and you want your investment to double, which means you want it to go from 1,000 to 2,000. So I'm going to plug in those values. So 2,000 equals 1,000 e to the 0.09 t. And so it's an example where we need logs in order to solve for time. So the first thing I want to do is get this e by itself. So I'm going to divide both sides by 1,000. And I get 2 equals e to the 0.09 t. And this makes sense because I wanted my amount to double, so this number here should be 2. So the way you solve for an exponent is I'm actually going to take the natural log of both sides. So I'm going to have the natural log of 2 equals the natural log of e to the 0.09 t. I'm going to show you a short trick in a minute, but first thing I can do is use the power rule, which says this exponent can come out in front. Okay, can come out in front of this natural log, and that's why that log helps me. So let's go ahead and rewrite that like that. And I'm going to have the natural log of 2 equals 0.09 t natural log of e. And now this natural log of e actually makes this problem a lot simpler. It won't always happen that you have something like this that will simplify really nicely, but you can put this into your calculator. You can take the natural log of e and you'll see the answer. Or you can remember the base here is e, so this is saying e raised to what power is e? And when the base and what you're taking the log of are the same, we said this always equals 1. Write this in yellow. So that's 1. So it's actually simplified, so just be natural log of 2 equals 0.09 t. So if this didn't equal 1, I would just divide both sides by natural log of e. But it can be, it goes away. So now to get t by itself, I'm just going to divide by 0.09. And then put this into your calculator. Remember, you do need to end the 2 with the parentheses to show that's your numerator. And when you do this, you should get about 7.7 years. That's how long it'll take for your money to double.